Okay. Reminder that CK12 1 through 4, sections 1 through 4, helped you out on the quiz, because with the quiz covered 1 through 4. So the CK12 5 and 6 will help you out on the test if you get it done by tomorrow. Okay. And then the review will give you 10%, up to 10%, depending on what you get on the review. How many of you are parents planning to come to parent-teacher conferences? Okay. Just know, like, when they ask how you're doing, I'll be able to go through and say, you know, they either do their extra credit or they don't do their extra credit. I mean, if they're not happy with your grade and you haven't been doing any of the extra work, I'm going to let them know, you know, that's part of the problem, that you're not taking advantage of extra credit. Because 10% on the test really helps. Really does. And then I will also go through with them, you know, the web work grades, whether you're turning them in, whether you're turning them in late, whether you've got zeros, and how much time you actually come in and ask for help. You know, I've got some students that say, I just don't get it. And when I tell their parent that they haven't been in to get any help, they don't ask questions in class, they don't come in before or after school, I don't know how else to help them if I don't know what they're not getting, right? So those are all conversations we'll have if you've got a grade that maybe your parent's not going to be happy with, just so you know how that will go. All right. Looking at the test review, there will be a problem like this on the test, the mixed nut problem. Okay, so if you have a hard time with word problems and putting them into equations, I'm going to do it now for you, and it might help you to go back and watch the video again before the test tomorrow so you get a better understanding. But when we look at this, it says macadamia nuts cost 90 cents per ounce, peanuts are 30 cents an ounce, and cashews cost $1.30 per ounce. You want a 20-ounce mixture of macadamia, peanuts, and cashews that cost 68 cents per ounce. If the combined weight of the macadamia nuts and cashews equals the weight of the peanuts, how many ounces of each nut should be used? So how many variables do I have? How many types of nuts? 3. So I'm trying to find the weight of all 3 of those. So I know I'm going to have how many equations? 3. Because I can't get 2 equations and solve for 3 variables. I have to have 3 equations to solve for 3 variables. So the first challenge here is coming up with 3 equations from the information that was given. Okay? I think the easiest part of the information is probably at the end, the combined weight of the macadamia and cashews. So I'm going to call M macadamia and cashews equals peanuts. Everybody see that? So I've got one equation now. I know that the weight of the macadamias and the cashews equals the weight of the peanuts. Okay? And I also know something that always helps me when I'm trying to figure out a problem like this is what's the units on M, C, and P? It says the combined weight, so the units will be ounces, or it's going to be weight. It's measuring weight, right? So if I multiply the weight of the macadamia nuts times 90 cents per ounce, what am I going to get? What's the unit on that? 90 cents per ounce times ounces gives me the dollar amount, right? That might come in handy because it tells me altogether that 20 ounces at 68 cents per ounce, well, if I take 20 ounces times 68 cents per ounce, I get $13.60. So the total price of all of this is going to be $13.60. And to get that total price, I'm going to take the macadamias times 0.9. I'm going to add to that the peanuts times 0.3 and the cashews at 130. So I'm just going to do 1.3C. Right? If I take the cost of the macadamias times how much I have of macadamias, plus the cost of the peanuts times how many ounces I have of peanuts, the cost of the cashews times how many ounces I have, on the left I'll end up with a dollar amount. So on the right it needs to equal a dollar amount. And it tells me there's 20 ounces at 68 cents per ounce. So altogether I'm going to spend $13.60. So there's my second equation. Everybody follow that? Okay, and my third, well, I want 20 ounces total, and each one of these nuts, M and C and P, are measured in ounces. So I know M plus C plus P altogether should be 20 ounces. I now have 3 equations. Okay, with this one, to me, I would use substitution, because I'm given an equation that's equal to P. P is equal to M plus C. Do you see how M plus C is right here? If I substitute P for M plus C, I have 2P equals 20, so I know how many peanuts I have right now. How many? 10. So that really quickly, I was able to eliminate one of the variables and say that I know I need 10 ounces of peanuts. Okay, now I'm going to plug 10 in to this equation and plug 10 into this equation, and I'll end up with 2 equations, 2 unknowns. So I have 0.9m plus 0.3 times 10 is 3 plus 1.3c equals 1360. And then I have m plus c plus 10 equals 20. Now if I just simplify, if I subtract 3 over, sorry, 10.6. See how easy it is to make a mistake? 10.6. And then here I have m plus c equals 10. I just subtracted 10 over. Everybody see that? So now I've got 2 equations, 2 unknowns. I'm just going to multiply this by negative 0.9 so I can eliminate the m's. Minus 0. This is an m. 0.9c equals 0.9 times 10 is 9, and it's got to be negative. With me still? So 1.3 minus 0.9 is 0.4 equals 10.6 minus 9 is 1.6. What happens if I just move the decimal over on both sides? Is that allowed? Yeah. Because that is a lot easier. C is then equal to 16 over 4, which is just 4. So now I know I need 4 ounces of cashews. 4 ounces of cashews, 10 ounces of peanuts. What's left to equal 20? 6 ounces of macadamias. Make sense? Okay, for the sake of time, I'm not going to go through and substitute those 3 into all 3 equations, but if you want to check your work, that's how you would do it, just to make sure. Okay, so the key here was finding 3 equations, because once you get 3 equations, hopefully by now you understand the system of solving 3 equations. Okay. If there's a word problem on the test, and all you do is you just substitute 3 numbers in to try and figure out which work, and you don't do the work to prove it, you just are randomly throwing numbers in until you find 3, I won't take it if you get the right answer. So make sure you know how to do the work on a problem like this. Okay? All right. Next problem, it says graph the linear system and tell how many solutions it has. Graph the linear system. So it's in standard form. So when x is 2, or sorry, when x is 0, y is 2. When y is 0, x is negative 3. Something like that. Next one, when x is 0, y is negative 1. And when y is 0, x is 1.5. Well, my graph's not perfect, but they look parallel. How could I just make sure, because I didn't do it perfectly, how could I make sure? Find the slopes. So in standard form, what's the fastest way to find the slope? Negative a over b. You guys are getting so good at this. Negative a over b. So negative a, negative 2 over b, negative 3, 2/3. What's the slope here? Well, this is tricky. A and b and c, a goes in front of the x, b goes in front of the y, c goes in front of the z if you had a z, or c is it's equal to c. Okay? So they've switched y and x, haven't they? So we need to put it in standard form to really see the slope, or you just need to recognize 2 is a, negative 3 is b. So negative a over b is also 2/3. So yes, my drawing is right. In fact, they are parallel. So how many solutions are there?
No.
None. None. They'll never cross. The solution is where they cross. That's the solution. If they never cross, there's no solution. Okay? Next one. Three x plus y equals 1. And 2y equals 2 minus 6x. I might go ahead and just convert this. Y equals minus 3x plus 1. And if I'm going to convert this, this one's pretty easy to convert. As soon as I convert them both, what do I find? It's the same line. What does that tell me for how many solutions there are? Infinite. Yep. What would you do to describe the infinite solution as a line? What is the solution as a line? Yeah, y equals negative 3x plus 1. You had to do that in WebWork for a couple problems when there were infinite solutions. Remember, you had to solve for y and say y equals whatever that was, because that is the solution. That line goes on forever, and everywhere that line is, that system crosses on the same line. So everywhere it crosses goes to infinity on that line. Make sense? Okay. Don't even need to graph this one. All right, now we're on to solving. Doesn't say how,
No.
so we can choose whatever method we want. At the first one, I will probably use elimination. I'm going to eliminate y's. Why? Why would I choose that, you think? Smaller numbers. One's a negative, one's a positive, so I don't have to multiply by a negative. That's always handy, because then I won't maybe mess up when I distribute that negative through. All right, 9x minus 6y equals 30, and 10x plus 6y equals negative 30. Now I get 19x equals 0, so x equals 0. Now I'm just going to plug that into either one of these equations. If x is 0, this is gone. I have negative 2y equals 10, so y equals negative 5. Just do a quick check on the second equation to make sure. 5 times 0 goes away. 3 times negative 5 is in fact negative 15. So my answer here is 0, comma, negative 5. Good there? Stop me anytime, because this is your day to review. Okay. Number 5. One of the things, hopefully, you kind of got in the habit of looking at when you were doing web work is seeing if you can do those factors. Meaning, what do I multiply negative 1 by to get 2? Negative 2. 2 times negative 2, negative 4. 3 times negative 2, negative 6. What does that tell me? They're the same line. Okay? If you didn't recognize it, though, let's go ahead and do this by elimination. So you can see algebraically what you get. I'm going to multiply this by 2. Okay? So if you can recognize that factor and see that they're the same line, you would have also been able to, like if you solved this for y and this for y, you would have gotten the same equation to tell you it's the same line. If you don't recognize that, though, and you just jump right into elimination, that's fine, but just understand when you get to this point what it means. So if you get to the point where it says 0 equals 0, that is always true. 3 equals 3, always true. 100 equals 100 will always be true. So that tells you there's infinite number of solutions that would satisfy that, because it's always true. And what it means graphically is that they are the same line. Okay, so the answer here on this problem is infinitely many. Good? All right. Number 6. I might do the same thing on this one just to check. 3 times what is negative 9? Negative 3. Negative 5 times negative 3, positive 15. Negative 10, because I had to have to move it over, right? Times negative 3, aha. It's not negative 30, it's positive 30. But these are identical on the left. Okay, so I could just do a quick negative a over b and check my slopes. Negative 3 over negative 5 is 3/5. 9 over 15 is 3/5. Same slope, but they're going to have different y-intercepts because I didn't get this on the left or the right to be equal. But I do know they're the same slope. So my hypothesis is there's going to be no solution here, that they are going to be parallel lines. Okay? But algebraically, I didn't do that. Let's say I didn't check. I just jumped right into elimination. So let's do the problem. I'm going to multiply. First, let's get the problem written with the 10 on the other side. That's a 5. Negative 9x plus 15y equals negative 30. I will probably just multiply this by 3 to get 9x minus 15y equals negative 30. Everything on the left cancels out, but I'm left with negative 60 on the right. When is 0 equal to negative 60? Never. Okay? When you get something like this that makes absolutely no sense and will never be true, you know the answer is no solution. Graphically, what that means is the two lines are parallel lines. Questions on that? There's a few ways you could have figured it out without having to do the whole elimination process by seeing if the factors work, right? But if you choose not to do that and you just want to jump into it, understand when you get an answer like this what it means so you know what the answer is. No solution here. Good there? All right. 7, 3 equations, 3 unknowns. So I'm going to go ahead and just label these like he does in the video. I think it's easier to just kind of plan your strategy before you jump into anything. Remember, I'm going to have to eliminate one of these 3 variables 2 times, and I need to eliminate the same variable. So I'm going to choose. What should I choose? X, Y, or Z? I've got a Z, I've got an X. There's no wrong answer. Why did you say X, Lacey?
Because one of them's a negative.
Okay. And another reason might be because if I just add or A and C together, I don't have to multiply by anything. But when I look at Z, I see that that's pretty attractive too, because Z has a 1 as a coefficient for that third equation. And so all I need to do is multiply it by negative 3 and then multiply it by negative 2 and add. They both are going to work. Let's just choose X. Okay? So I'm going to just map my strategy out before I jump in. So my strategy is going to be to add A and C together. That's my first equation that's going to eliminate X. So I'm going to end up with an equation with Y and Z. Okay? And then I'm going to multiply B times 3. And I'm going to add that to 2 times C. So if I multiply this by 3 and this by 2, I should get my x's to cancel. Everybody see that? Okay, so A plus C, I end up with negative 3y plus 3z equals negative 12. That one's pretty easy because I don't have to multiply by anything. To do the next one's going to be a little more work. So I'm going to multiply everything on the B equation by 3. 6x plus 9y plus 9z equals negative 6. Don't forget to multiply it by the constant. Then I'm going to multiply 2 times, oh, I already messed up, didn't I? Nope, I didn't. I was thinking I multiplied it by c, but I didn't. I multiplied it by b. All right, now I'm going to take 2 and multiply it by c. Negative 6x minus 10y plus 2z equals negative 18. Okay, how many of you got through all the way through a 3-equation, 3-unknown problem in web work and realized your answers were wrong? Let me see a show of hands. Yeah, about everybody. Typical, they're hard, and you make one little mistake along the way, you have to go back and find it, right? So a recommendation might be when you do something like this work, maybe take a minute and do it one more time in your head. And just check these 2 equations before you move on. If you can check your work a little bit as you go, chances are when you get to the end it should be correct. Rather than just go through all the work and get to the end and they're all wrong, and now you've got to go through all that work and figure out where you made a mistake. You know what I'm saying? Okay, so I'm just going to do it real quick. 3b, 6x, 9y, 9z, negative 6, check. 2c, negative 6x minus 10y plus 2z, negative 18. Okay, I feel okay about that. I'm going to add these 2 together. I get negative y plus 11z equals negative 24. And just make sure, I have a positive 9 and a negative 10, so that should be negative 1. These are both positive, so 11. These are both negative, so I add them and keep it negative. So I'm feeling okay about that one too. Okay, so now I'm going to label this D and this E. Now my strategy, when I look at these 2, I'm definitely going to work on the Y's, I think, and not the Z's, because I've got an 11Z and a 3z, so I'm going to have to do something with both of them there. But because I only have a coefficient of 1 in front of the y, negative 1 really, it should be a lot easier to figure out. So I'm going to take negative 3 times e and add that to d. Because when I make this negative 3 times negative 1, it'll give me a positive 3y. When I add, my y's should drop out. Okay? I'll rewrite d right here. And then I'll go ahead and multiply everything in e by negative 3. Negative 3 times 11 is negative 33. Negative 3 times negative 24, positive 72. When I add these together, y's drop out. I'm left with negative 30z equals positive 60. So z is negative 2. Yay, I finally found 1. What do I do now? Ethan, you have any questions?
No, I don't.
Okay. Z back into which equation?
3y minus.
33z.
Yeah, one of those.
Okay. 3y minus 33 times negative 2 equals 72. Doesn't really matter. I could have picked this one too. So 3y plus 66 equals 72. Six. Y is 2. Now I'm going to take 2 for y and negative 2 for z and plug it back into one of these. I'll just pick this one. So 3x, because I don't know x yet, 2 times y is 4. 2 times negative 2 for z is negative 4 equals negative 3. Those go away. So I have 3x equals negative 3, x equals negative 1. So now I'm going to take just a minute and I'm going to plug those 3 back into the second equation and the third equation, just to check. Negative 1 times 2 is negative 2. 3 times 2 is 6, so that gives me 4. 3 times negative 2 is negative 6. 4 minus 6 is negative 2. Negative 3 times negative 1 is 3. Negative 5 times 2 is 10, negative 10. And z times z is just negative 2. Does that equal negative 9? 3 minus 12 equals negative 9. Check. So it works in all 3. So that is my solution. And I would write my solution as negative 1, 2, negative 2, x, y, and z. Okay? Long process, lots of places for error, but it's not hard math, right? It just takes time. When we learn matrices next chapter, you'll be able to do this problem in about 30 seconds. All right, graphing. This board does not follow my eraser very well. Okay. We like Desmos, right? It really was nice in 3.5 to have it. But I told you, you've got to know how to do it manually. Okay? Well, I'm not going to have a crazy system like we did in 3.5. So I'm hoping that the difficulty of 3.5 and having to be able to figure out where things are shaded will make a problem like this really easy. But if you've relied on Desmos solely in 3.5, that might make it more difficult if you're still struggling with graphing. So if I'm going to graph this system, they're both in standard form, so I'm going to use the intercept method. When x is 0, y is negative 1. When y is 0, x is negative 1. So it's going to be solid or dashed? Dashed. And I'll worry about shading in a second. Let's graph the second one. X is 0, y is negative 2. Y is 0, x is a little more, about a third more than 1, right? So it's just going to be somewhere in there. Solid or dashed? Dashed. Looks like that. Is 0, 0 a point on either one of these lines? No, so I can use it as a test point. And what that means is I'm going to put 0, 0 in for x and y. So when I do that, I get 0 greater than negative 1. Is that true? Yes. So for the line, it's this one. For this line, 0, 0 is in the solution. So I shade the side that has 0, 0 in it. Okay. Next, I'm going to use 0, 0 again. Is 0 greater than 4? No. So 0, 0 is not included for the solution of this line. So I'm going to shade everything on this side. And I can already see the area of overlap now. Right? It's this right here. And it goes on forever unbounded. Okay. If I had a third line in there, I could, get a shape or something like we were working on in 3.6 with triangles, but this is unbounded. And so you get half a point for graphing the lines correctly. You get a quarter of a point for choosing the right type of line, dashed or solid. And you get a quarter of a point for shading. So don't forget the dashing and shading. It's really hard to get the problem right, though, if you start off with the wrong lines. Okay, so if you are someone that's still struggling with graphing equations, it might not hurt tonight to do some practice problems. All right, and the next one looks like it's going to be easiest on the first one to get it into y equals mx plus b. So I'm going to go ahead and just divide everything by negative 1. What does that do to the sign? Flips it. Let me get back to blue here. So there's one equation. Flip the sign, divided everything by -1. Okay, and then the other is less than or equal to, why did I put 0 there? I don't know. -2. Okay, the y-intercept is 3. My slope is 2. And it's a solid line. Here, it's a solid line, and it's a vertical line. Anytime x equals 0, or x equals a number, it's always a vertical line, because everywhere on that line, x is -2 in this example. Now I'll figure out, is 0, 0, can I use 0, 0 as a test point? Yes. So is 0 greater than or equal to 3? No. So it's not going to be part of the solution. And then I don't even need to do a test point, because it physically says all numbers less than or equal to 2. So it's going to be this side. And there is my unbounded shape with a vertice here and here. See that? Okay. All right, last problem, word problem again. The nice thing about this one is there's only 2 variables, right? Postcard stamps and letter stamps. So I only need to figure out 2 equations, thank goodness. So if I say P is the number of postcard stamps, and L is the number of letter stamps. That's what I'm going to define my variables to be. Okay? So if I take the number of postcard stamps times 20 cents and add to it the number of letter stamps times 33 cents, I should have it total $12.60. Notice I don't multiply 50 times 12.60 because 12.60 is the total amount of my purchase. It didn't give me an average price of stamps they wanted. With the nuts, they said they wanted to average 68 cents an ounce, and we multiplied by the number of ounces they wanted. With this one, they tell us they want to spend $12.60. They want to buy 50 stamps, spend $12.60. So $12.60 is the total. And when I take the number of stamps times 20 cents per stamp, I get dollars, right, as my unit. So dollars on the left, dollars on the right. I always use that strategy to check whether I've got an equation right. Do I have the same units on the left as I do on the right? If not, I've messed up something in my equation. Okay, what's another equation I could use here? I need 2. P plus L equals 50. The number of stamps total that I want is 50, and I only have 2 types of stamps, postage, or postcard and letter. So if I take the number of postcard stamps plus the number of letter stamps, I should get 50 stamps. Good. Okay, I could do either substitution or elimination pretty easily. So, solve for P here and substitute it in. I'm just going to use elimination. I like elimination better. So I'm going to multiply this by -0.2. And I'm going to move up here to do my work. Okay, so I'll rewrite my first equation. And when I multiply through by -0.2, and 0.2 times 50 is -10. .33 minus 0.2 is 0.13. 1260 minus 10 is 260. If I go ahead and move this over again, like I did before, So 20 letter stamps. So now how many postcard stamps? 30, because I need a total of 50. Okay, again, if you get to a problem like this and you don't know how to do it, and all you do is sit there for 10 minutes and plug in numbers until you get it to work, and then tell me the answer and it's right, I'm not going to give you credit. Need to see your work. Okay? I don't want you spending time in the ACT just plugging and guessing, and just do the work and move on. Get it done. Don't waste time just guessing numbers. Okay? Questions. 3 equations, 3 unknowns. 2 equations, 2 unknowns. Graphing systems of inequalities. Okay? If word problems are something you struggle with, go back and watch this video. Okay? If graphing is something you're still struggling with, practice graphing. Know what your weaknesses are and work on it so you can do well tomorrow. All right? Test tomorrow. No school Friday.